Okay, so this part is very slightly related to the glideinWMS. Definitely doesn't tell you how to configure stuff, but how to use it. So since, again, this was extracted from the talk Todd gave last year, most of it. So as I said before, Condor is a workload management system, it's a bad system, it's not quite like before. And Condor people really care about the scientific community, which is why they're here. Again, what you can do with Condor, local processes, cluster, blocking, glidins, Condor key. And in this talk, I will essentially cover the local cluster and glidins essentially as one thing, because from the user point of view, they're really the same thing. If things are done right, users should not really notice any difference between a dedicated local pool and a gliding pool. So, how do you submit to Condor? Well, first of all, you have to get access to a submit node. Choose a universe that is reasonable for the jobs, and we will use vanilla. Make your job batch ready, which means having all the data available that you need. Create the submit description file, run Condor submit, and then relax. Condor will do everything for you. At least maybe. Most of the time, that's exactly what needs to be done, not all the time. So, what is this universe? So, it essentially controls how Condor handles jobs. And Condor has many types of universes. As I said, what we will really talk about is vanilla universe, which means essentially a single node, single process job. You have parallel jobs like MPI, not that Condor is really good at it, but they can support them. Grid jobs, which is on the factory, we will not talk about it. We have a Java universe job, which is essentially the same as vanilla, but it already starts inside the Java VM. This you can actually use in the glidins, although we typically don't support it out of the box, but we could, with very little change. It actually supports the VM universe, which will start a virtual machine on behalf of the user. So essentially Condor can be a cloud interface for certain definitions of cloud. And then there is the standard universe, which is vanilla++, which needs special compilation and allows for a lot of other things, but it's very restrictive too, so not many users use it. And I'll definitely not go into it. So, what is the simplest Condor job you could run? Assume you have a binary called Cosmos that you need to run. This is the submit file you would want to write. So essentially say vanilla universe, executable is Cosmos, any arguments you need, your standard output, any standard input that if you need, and where you want to log what's going on with your job, and then you say queue. That's about it. That's pretty much the shortest submit file you will ever use. Once you have it, run Condor submit your file. In this case, we call it sim.submit. And Condor skeptic takes it into its hands and says, done, I have it, and this is the cluster ID. You can use Condor queue to see what's going on with the job. And I suppose I have freed up the user. And if you do Condor queue, you see that it's in the queue. Okay, so it was a different submit file because it's simple text exe instead of Cosmos. Apart from that small detail, it's idle, which means it's waiting to find a machine to run it. Once it's running, this will get to R, and once when it's finished, it will get out of here completely. So you don't see the completed jobs; you see only jobs that need to be completed with Condor queue. As we said, everything is Condor is class ads. So if you want to know exactly what the class ad for your job is, do Condor queue minus long, possibly with the job number, if you're not the only user, because else you will get millions of lines of code you probably don't want to. But assuming this is the only one, you see my type is job, I want a machine, this is my cluster ID, this is when I was queued, This is who is the owner, the user that actually submitted it. And have I used any CPU or have I ever exited, which is of course 0 because I haven't started it. So you can use Condor Q to monitor the progress of your job, but that's heavy both in terms of the client because you actually have to fork processes, and it's heavy on the schedule because the schedule can actually have to do something actively every time you do it. Instead, you can use the log file. You remember we had the log file in the submit file, this cosmos.log. That log file will have entries like this. Every time a job is submitted, starts running, it's preempted, restarted, terminates, you will get a line in the log. The various states, so this is the job ID, these are the various states, and this is the date, and then you have the human readable part of it. Condor manual has some documentation on how to parse it, but it's not really that difficult, and it's really efficient if you want to monitor what's going on with your jobs. And if you ever want to automate monitoring of all jobs, you should do it that way, not Condor Q. It has pretty much all the information that you would get from Condor Q. The other part of the equation is Condor status. This gives you information about the pool, essentially what machines are available. In case of the glidings, you may start with an empty pool, but it will grow up as the glidings are submitted for you. And if you use Condor status, this is pretty much what you get. You get the machine name, operating system, architecture, is it in use or not. So essentially claim busy means it's in use. Anything else means it's not in use. How much the node is loaded, how much memory is available, and how long has it been in the state. This is there. And as before, Condor status minus long will give you the complete class ads, so you can look in detail what is there. That's especially convenient if you want to figure out why the heck it's not matching. There are many other commands that Condor supports. We see Condor submit. Condor run, it's similar to Condor submit, but it will wait for the job to finish. This is useful if you have a job that is expected to run only a few seconds, and it's expected to match immediately. So it's a nice tool for debugging purposes. You will probably not want to use it for anything automated. Condor Q we've seen, Condor state we've seen. Condor RM, you decided you submitted the job by mistake. This is how you get rid of it. Condor history will tell you about the job that you completed. As I said, Condor Q will only tell you about jobs that still have to complete. The moment the job completes, it gets removed from the schedule and moved into a history file. Condor history is how you get this information out of the file. And then you have Condor hold and Condor release. Condor hold essentially means keep it in the log but don't start it. Condor release says, okay, a job that was in hold, put it back in an active state so it can actually be matched. And essentially, Condor Q, Condor status, Condor RM, hold and release can be used from remote with appropriate care. Condor history is strictly local, and Condor submit and Condor run, while in theory can be used from remote, it's not really usable because of file transfers and stuff like that. So just for the record, everything is usable locally to the schedule, of course. Few words about Condor file transfer. Condor can transfer files between the submit and execute nodes if you so desired. By default, out of the box, it will try to use NFS, shared file system, which, especially in the gliding case, forget about it. You will never get it. So if you want to file transfer, you should put in your submit file, should transfer files, yes, or if needed. And this will make sure that Condor actually does the file transfer between Condor daemons internally without requiring any shared file system. If you do it no, you better have a shared file system or jobs will never start. And the other part of the equation is telling when you want the files back. And you, by default, most people set it on exit, essentially. When job finishes successfully, bring back the files. The other option is on exit on evict, which essentially says if the startee needs to preempt your job for whatever reason, still bring back the files. This is useful if you want to implement checkpointing essentially in the user space. So if your job continuously writes something into a file, and if your job is killed, the file is brought back, and then the next start is brought back, sent back to the next worker node, and you can restart from where you started, when you left last time. That's something that allows you to implement poor man's checkpointing mechanism. In addition to that, if you want the files to be transferred to the worker node, you have to tell Condor what you want to transfer. By default, it will transfer just the input file. If you want anything else, you better list them. For output files, it's slightly more tricky. You can list all the files with transfer output files. In this case, it will transfer back the files you listed, and they better exist, because if they don't, the job will fail. If you don't specify the files, the transfer output files, but you still ask for file transfer, it will transfer anything that was left in the directory the job started in. Good or bad, everything will be brought back. So usually it's better to let Condor bring back everything you need. Simply this way the job always succeeds. I usually recommend first thing in your job, create a subdirectory, move into it, create all the bad files in there, and at the end of the job move whatever you want to transfer back in the home, in the directory you started in. This way, if anything goes wrong and you fail miserably, nothing will be transferred back. And if you succeed, you will get back what you need. The other option is that you list the transfer output files and the transfer input files with an empty file, so you are guaranteed that that file is actually there to be transferred back. It's a little weird, but it works. So here is how the submit file that actually does file transfer look like. So it's like before, we just added a few lines. We said we want the file transfer, this is the input file, this is the output file, and I want it back on exit. And this is probably the minimum. I don't have a standard output and stuff like that. It didn't fit on the slide. Should be there. So if you merge this and the previous one, that's really the minimum you ever want to run. The minimum the submit file you ever want to use for anything real. Now, Condor will send an email every time a job finishes, by default. That is the default. Which is potentially nice if you have 10 jobs in the queue. But if you have 10,000, you don't want 10,000 jobs to get to your email box as the jobs finish. So, personally, I would recommend you always put notification equal never in your submit file, so you don't get those emails. I find them annoying, so that I might be biased, but you should know about it. Now, sometimes you want to parameterize your job. You want to know what job ID it is, so that if I submit 10,000 jobs with the same executable, I have a way to distinguish between them. So, Condor, when you submit, you get a cluster ID and a process ID. If you submit a single one, you get a cluster ID of something, a process ID equals 0. As you see it in the example. Here, when I submit it, I got a cluster of 1, and since it's a single job, the process was 0. You can actually reference them with $cluster and $process, and you can put them anywhere, in an attribute, in your arguments, in your environment, so that the job can actually use them to do something about them. Use them as seed or whatever. For monitoring purposes, we use a lot of monitoring purposes in the glideinWMS itself. You can of course add any arbitrary attributes. And they can be both as mnemonic. For example, it's just easier when I have 10,000 jobs and I submit some for Higgs, some for B analysis, and something for, I don't know, pick your own. I mean, it would be nice to see which ones are which. So for your own mnemonic, you can add something like the annotypes is Higgs. So when I do a Condor queue, I can actually constrain and say, show me only the jobs for the Higgs analysis. And this is for your own purpose. Nobody else will ever look at them, but it's just nice and easy. But you can actually use them for something practical, like matchmaking. And for example, in the glideinWMS, you have seen the examples. You add desired site equal Fermilab, UCSD, Nebraska, and somebody actually interprets that and acts on it. So you will only run on these sites, for example. They are perfectly equivalent from Condor point of view. When you submit the job, Condor doesn't really care if it's one or the other. They are just attributes that are not standard for Condor. And in order to add any attributes that Condor doesn't recognize, you have to put a plus sign in front of it. So you have to do something like plus desired site equal blah blah blah. Because if you don't start with a plus, Condor will complain that it's an attribute that it doesn't recognize. So this is how you distinguish between standard and custom attributes. In the end, in the class that's the same. It's just the Condor submit will complain if you don't. So here you have a little more complicated submit file. We added in the arguments a cluster, so each job will be slightly different. With disable notification, we added a mnemonic, and we said, oh, this is actually for glided. I want to run at this site. Actually, put back the log. And there are many more options available. I just barely scraped the surface. You have the Condor manual, see the Condor wake user tutorial. It provides lots of information. And I just got the most interesting ones that you may want to use. But definitely, you don't need to stop here. Now, a few words about priorities. Now, let me state what priorities I'm talking about. Priorities between users are set by the negotiator administrator, and we will have a section about this tomorrow. Users really cannot influence. You cannot force yourself to get in front of somebody else. But you can set priorities relative to your own jobs. So by default, when you submit jobs, one after the other, they will be matched and executed one after the other. However, you may have a need 3 days down the line to start a job sooner than everything that you have submitted before. So you just say, oh, this is really important. I want this to start as next available resources, but I have 10,000 jobs in the queue. You don't want to remove all the other jobs just to get the new job started, right? So for that, you can actually set a priority factor of the job so that this job will get ahead of the queue. So essentially, Condor essentially has prioritized FIFOs. In every priority level, you get FIFO, and the highest priority FIFO will be exhausted first before any other will be considered. And how you do it? Condor prior, it's what changes it, and you actually see it with Condor queue. So assume here I have Frida with a job much later than the 1.0 we've seen before, and yeah, he has a single job in the queue, so it doesn't matter too much. But let's say actually this is good, and I want to change this priority, and I set to -10. -10 means this can start whenever there is something. If I submit something later on, we'll get priority over this. This is just as a backfill. I don't care whenever it starts. I can wait. If I put it to +10, it will be the first in the queue, pretty much. You can actually put this information in the submit file itself. It's what is job priority equals something or something like that. Look into the manual. And if you submit something like backfill jobs, you may need that. But you can definitely do it in runtime too. probably should put the submit file description over. Workflows. So the HTC, which is high throughput computing, everybody knows that, it's about using many CPUs. And when you have many CPUs, you probably don't want to submit one job or two. You will usually have thousands, tens of thousands, millions of jobs. And a workflow is essentially a collection of jobs for solving a single task. So if you are high energy physics, where all the jobs are the same, no dependencies, yeah, you do queue 10,000, submit, forget, done it. If you are somebody like LIGO that have dependencies, fan in, fan out, jobs that do one thing and then need the output from the other, you don't want to do that by hand, and you want something that actually automates your dependency handling. And Condor provides a tool to handle dependencies, which is called Condor Tagman. You can use higher level tools like Pegasus, and if you have any questions about Pegasus, Matt, I'm sure, will be very happy to answer them. But under the hood, in the end, Pegasus uses Tagman tool. So what is the Tagman? Condor Tagman is really a program to manage a DAG, where a DAG is a direct acyclic graph. Anybody that has done any basic CS stuff knows what a DAG is. So here's an example of a DAG. These two need input from this one, these three need input for this one, this needs for both of this, and this for this two. And you can give a DAG like this Tagman, and it will schedule it in such a way that it finishes in the shortest possible amount of time. If you look by hand, you can see that at most you can run 4 parallel here, right? Which is this three. You cannot do better than that. Everybody else needs some dependencies. And you want these two to be submitted after this was finished, or these two will fail. Stuff like that. Tagman is exactly what does this kind of things for you automatically. And it will, if anything goes wrong, it will create a partial DAG so that you can fix the problem and start from exactly where you end it, and you don't need to start from scratch. Nice is like that. Something that I personally don't like is that you have one running program, one process per DAG. Essentially, Tagman is a process that is launched in the local universe. It's actually just a program. So for each DAG, you would have one. So if you have lots of DAGs, that can be a lot of processes. May not be a problem, but personally, I find it annoying. How to submit a workflow? In a nutshell, you create the submit files of all the nodes. So each node is a job, so you need to have a submit file for each job. You can parameterize it, of course, to first approximation. Create a Tagman submit file that represents the DAG. And here is an example of the Tagman file that represents exactly that one. And then just run Condor submit DAG. And Condor will do the right thing. Start the Tagman will read the file, submit files, do it everything you want. And there you have a link if you want to investigate a little more, or go to the Condor tutorials that were in one of the previous slides. And this is all I have. So if people have questions, this is the right moment.